Hi folks, let's try solving some logarithmic equations today. So let's begin by solving for x in the equation log base 3 of the quantity x minus 5 minus log base 3 of the quantity x plus 7 equals 2. We have a beautiful law of logarithms called the quotient rule there that will allow us to make this a little bit easier for ourselves. So we can combine those first two logarithms on the left hand side of our equation and make it log base 3 of the quantity x minus 5 in the numerator, and then x plus 7 appears in the denominator, and all of that equals 2. And the only thing we did is just use that quotient rule for logarithms. Now, by the definition of logarithms, we can rewrite this as just x minus 5 over x plus 7 equals 3 squared. If you don't like that format, you can raise both of these, log base 3 of x minus 5 over x plus 7, and the 2 go 3 raised to those powers. Put them up in the exponent and you'll see that the 3 and the log base 3 cancel out on the left hand side. Either way, you get to this result. So now what do we do? Well, the right hand side equals 9, and we have a fraction on the left hand side with two x values. And the way to solve for that fraction, we multiply both sides by the denominator. So we have x minus 5 equals 9 times the quantity x plus 7, and this is more of a simple linear equation that we can solve. So just distribute the 9 to both terms, and so we get x minus 5 equals 9x plus 63. Now all we need to do is just add the 5 to both sides, and so we get 9x plus 68 on the right hand side equals x, and now subtract 9x from both sides, you get negative 8x equals 68. And then we have x equals 68 over negative 8, or negative 17 halves, which is approximately, well, not approximately, negative 8.5. So there's one caveat though. When we have these logarithms, we have a restricted domain. So just remember that the log of x is equal, not equal, but it has a domain of x greater than 0, but we have log of x minus 5 and then a log of x plus 7, right? So the x minus 5 has x greater than 5 as its domain, and the x plus 7 has x greater than negative 7 as its domain. And so what that means is overall when we combine those, x greater than 5, that has the fewer terms, so that's what we're going to use. So the value on this x had to be greater than 5. Unfortunately, negative 8.5 is not greater than 5, so there's no solution. And this is the trick to a lot of these types of problems. There's a domain check that we have to go through. And so since our solution is not greater than 5, which is our domain, we have that there is no solution for this problem. Even though we solve for an x value, there's no solution. This is essentially an extraneous solution. So no solution for this one. Let's move on and see another one and how it works out. Solve for x in the equation log base 2 of the quantity 8x minus 2 minus log base 2 of 4 minus x equals 4. So now with that minus sign in between, we can use our quotient rule for logarithms. Combine those, you get log base 2 of 8x minus 2 over 4 minus x, and that all equals 4. Now just by the definition of logarithms, we can rewrite this as 8x minus 2 over 4 minus x equals 2 to the 4th, and that 2 came from the base of the logarithm. We can expand it over to the other side, and 2 to the 4th is 16, and so we have 16 on the right hand side, and notice that 4 minus x in the denominator. The way to take care of that is to multiply both sides by 4 minus x, and then the denominator will cancel off with that 4 minus x on the left hand side, and you're left with 8x minus 2 equals 16 times the quantity 4 minus x. Now just distribute the 4 minus x, or the 16 to the 4 minus x, and you have 8x minus 2 equals 64 minus 16x. And from there we can add the 2 to both sides, so you get 8x equals 66 minus 16x. Now add 16 to both sides, you get 24x equals 66. And now divide both sides by 24, and you get x equals 66 over 24. One last thing we need to do here is the domain check. So we have two logarithms involved again. So the 8x minus 2, we would need that inside of that first logarithm to be greater than 0. So what you get is x is greater than 1/4. And on the 4 minus x, what you actually get is, in order for that to be greater than 0, you need x less than 4. So it has to be a number between 1/4 and 4. And notice this is 11 over 4, which is between 3 and 4. So we're good. I'm sorry, between 2 and 3. So it's 2 3/4 essentially. But we're still good, is the moral of the story here. So what we have is a nice solution that works and fits inside our domain. So x equals 11 over 4 is our solution. You can plug that in and check it in a calculator if need be. So moving on. Solve for x in the equation log base 5 of x plus 2, that quantity there, and then plus the log base 5 of the quantity x minus 2 equals 1. Taking a look at this problem, we're going to need to use the product rule for logarithms. And the product rule states that when we have that plus sign between the two logarithms having the same base, we can just multiply those on the interior. So this becomes the log base 5 of the quantity x plus 2 times the quantity x minus 2 equals 1. And from there, well, we can use our definitional logarithms to rewrite this as the quantity x plus 2 times the quantity x minus 2 equals 5 to the first power, and the 5 coming from that base of that logarithm. Okay, well, where do we go from here? Well, we can actually expand that on the left-hand side, and you get x squared minus 4 equals 5. And moving forward from that part, you get x squared minus 9 equals 0. And we can factor that nicely. That's just x plus 3, that quantity times x minus 3 equals 0. And so we have x plus 3. You set each part equal to 0, x plus 3 equals 0, and x minus 3 equals 0. So that means x equals negative 3 and x equals positive 3. But wait one second, we have to do a domain check here. In the domain check, you have x plus 2 being greater than 0. That leads to x greater than negative 2. And then in the case of x minus 2 being greater than 0, you get x is greater than 2. Combining both of those, you want basically the overlap, and that would be x being greater than 2. And the only value where x is greater than 2 out of these two choices is x equals 3. So x equals 3 is the only solution that fits inside our domain here.